All right, guys, let's look at the first example on worksheet number 6. Okay, so the given is that BF bisects angle AFC, which we're already given that, but BF bisects this angle right here. So this is a bisector. Okay, so I need you to ask yourself, what does it mean to bisect something? Okay, what does that cause? And if you don't know the answer to that question, look at those cheat sheets, and on there it should tell you angle bisector. Okay, well, to bisect something means to cut it equally in half, so it cuts it into 2 equal parts. So if this bisects this angle here, that means that angle 1 has to be congruent to angle 2. And that's just by the definition of bisect. Okay. So number 3, it tells me that angle 1 and angle 4 are vertical angles. So here's 1 and here's 4, they are vertical angles. Well, guys, if you know what vertical angles are, you can look at this diagram and see that they are in fact vertical angles. So that would just be definition of vertical angles. Okay, now 3 to 4, it says angle 1 is congruent to angle 4. So look on that cheat sheet and tell me what it is that says if 2 angles are vertical angles, then they are congruent. That would be the vertical angle congruence theorem. Vertical angle congruence theorem tells you if 2 angles are vertical angles, which we showed in step 3 that they are, then they are congruent. All right, so now I'm going to look at line 2 and line 4 together. Okay, so notice angle 1 is congruent to angle 2 and angle 1 is congruent to angle 4. So both 2 and 4 are congruent to 1, so I could say that angle 2 is congruent to angle 4. Okay, and all I did is I substituted the 2 in for the 4 here, so I substituted line 2 into line 4. Okay, now if angle 2 and angle 4 are congruent, doesn't that mean they have to be equal? We've done that a million times. That's just definition of congruent. And that concludes our first proof. All right, let's look at our second proof here. All right, so we're given that BAC is a right angle, and if we look, it already has the box, so that's helpful, so that's given. And then it's also given that angle 2 is congruent to angle 3. That's given as well. All right, well, on number 3, we have a blank on the left, but on the right it says definition of a right angle. Okay, well, it tells us here BAC is a right angle, so doesn't that mean that angle BAC has to equal 90 degrees? Because isn't the definition of a right angle an angle that's 90 degrees? All right, now I'm kind of like, what do I do? So if I look back to this diagram, can I use the segment addition postulate, or sorry, angle addition postulate in this diagram here to the left? Okay, couldn't I say that angle 1 plus angle 2 equals angle BAC? That's the angle addition postulate. Okay, well now, notice if I look at 4 to 5, the only thing changed is this angle BAC became a 90. Okay, so how can we just change a BAC to 90? Well, this line allows us to do that because angle BAC is equal to 90 degrees. So I can substitute it in. So substitution, and I substituted line 3 into line 4. Okay. Now, angle 2 equals angle 3. This is kind of jumping around a little bit, but here we're given that angle 2 is congruent to angle 3. So if they're congruent, they have to be equal by the definition of congruence. Okay, now if I want to look at 5 and 6 together. Okay, I eventually want to show that 1 and 3 are complementary, which means I want to show that angle 1 plus angle 3 is 90 degrees. Okay, well, can I rewrite line 5 using line 6? Okay, so can I change the 2 in line 5 to a 3. Because they're equal, so I can. So I can say that the measure of angle 1 plus 1, now I'm going to change this 2 to a 3 because they're equal in line 6. Measure of angle 3 equals 90 degrees. And what I did is I substituted line 6 in for line 5. And now because angle 1 plus angle 3 is 90, that means they have to be complementary just by the definition of complementary angles.